Hello, in this video we are going to work on lab 303 where we'll see how to make ER diagrams. In the last video we looked at question 1 and identified the dimensions, the measures and the fact. Now let's go ahead and make a database diagram based on this information. To draw a database diagram we'll use an online tool called diagrams.net. Open a new browser window and you can type diagrams.net, which will take you to the online tool. You can just go ahead and you don't need to start making a profile or anything. You can just start from here and save the diagrams to. Let's say you want to save it either on Google Drive or device. So let's say I want to save it on Google Drive. It will ask you to authorize it. You may have to give permission. So go ahead and log on to your Google Drive. Otherwise, what I like to do is, a lot of the times I would save my work on the device that I'm working. So you can choose whichever way you like. Then let's go to create a new diagram. The diagram that we want to make is an entity relationship diagram. So I will choose the one which says entity relationship diagram. Let's go ahead and create. Now it will ask you to give it a name, so save it somewhere first of all and remember where you are saving it. For now, you may save it in documents on whichever computer you're working. And this assignment is about auto repair shop. So let's just call it auto repair ERD or entity relationship diagram. Go ahead and save. By default, it gives you a template. You can work with this template. But for this problem, I'm going to get rid of this and you may not need everything that is on there. So I'm selecting everything using my mouse and hitting the delete button. I will show you how to build a model from the scratch. So there are several tools or tool sets on your left hand side. You go to the one which says entity relation. Within this, you will see a lot of components that you will need for your entity relationship diagram. Let's look at some of these tools. To indicate a table, we can use either this table icon, which just shows the primary key, or we can use this other one, which shows an associated table with primary key as well as foreign key. If you think that you have to remember different kind of tables, maybe you can use the simple one where you can indicate primary and foreign keys by hand. So what we are making is a very simple type of diagram. We can just get this one. And where it says list, we are going to write the table name. Let's start with the table mechanic. So dim underscore mechanic. I started with dim to indicate that this is a dimension table. The first field based on our description is the mechanic's ID. So the problem description said a mechanic will inspect the vehicle. It doesn't have any attributes of the mechanic. But we do know that as soon as we have a dimension, we need to have a primary key. And usually people like to have IDs as a primary key. And then if they are a mechanic, we will have they are a person. So we will have certain characteristics or attributes to define who they are. Normally, whenever you have a person or an employee in a database or data warehouse tables, you want to indicate their ID, what are their first name and last names. Maybe if they have a title, since they are working in a facility, so maybe when did they start working, their hire date or start date. Sometimes you may have even their contact information, things of that nature. Okay, although our problem description didn't give us many details about the mechanic, but as we discussed, we can have some fields that would be there normally. So let's say mech ID is the mechanic's ID, and I would indicate that is the primary key of this table. The other field is going to be, let's say, first name. The next field is going to be last name. And if you want to add more rows, you can click here on this blue arrow. It will keep on adding rows. So let's say we add a few and edit them. I'm going to say the title of the mechanic. And this one I'm calling as start date, when they started working at this facility. So For now, let's keep it to this. If your problem description gives you more details, you can add more fields. Also, next to these fields, you can also add what data type each one of these is. In this case, not much detail was given in the problem description, so I'm not doing that. But in future, if you want to say, let's mechanic ID usually can be integer, first name varchar 25, last name varchar 25, title varchar 25, start date can be a date. So you can also specify the data type next to it. Going back to our problem description, another dimension was service. So what attributes do we have for service? So we have service, then we have service code and description for the service. So let's have these two attributes, and we are not going to add any more here. So again, I would drag this table, and then again, this is a dimension table, so dim underscore service, and my first field is going to be service underscore code. Again, this is going to be unique to every service, so I'm declaring this as the primary key of the table. And then the next field is going to be serv underscore description, just to indicate that this is the service description. This last field, I don't need it. So what I can do is highlight the entire row and hit the delete key. That will take care of it. Going back to our problem description, the next one we have is vehicle. So what do we have? Each vehicle is serviced of a certain type. So we need vehicle and type of the vehicle, and we also need make of the vehicle. No other attribute is given for vehicle, but we know that just having the type and make is not enough, so we can have some other fields as well. So let's again go back here, find this icon, call it dim underscore vehicle table. I am making up an ID for this one, vehicle underscore ID, and this field will uniquely identify every vehicle, so let's call it primary key. The fields that were given was make of the vehicle and the type of the vehicle. So let's indicate those, and based off our common knowledge, I know that usually for a vehicle it also matters what is the model of the vehicle. So let's put that as one of the fields. We can also put year as one of the fields. So that, if you want, you can also put who is the owner of the vehicle. So let's put who is the customer of that vehicle. Now, so we are done with vehicle. The next dimension we had identified was diagnosis, and it says each diagnosis, this is going to be our dimension, has a code and a description. So two attributes for diagnosis have been identified, diagnosis code and diagnosis description. So like before, I'm making diagnosis table, and this time I would indicate the primary key to be diag underscore ID. And then go to the next one, and just to differentiate it from the service description, I would give the name as diag underscore description. Once again, the last row, I don't need it. I can highlight the entire row, hit delete. So we have 1, 2, 3, 4 dimensions table ready. The next dimension table, which we did talk about in our description, was usually whenever you are dealing with a case like this, whenever somebody is asking you what date, what time, then you want time to be one of the dimensions. So the norm for time is that you will create it as one of the dimension. You can call it time, you can call it period, and give it an ID, and then break it down into different units of time, such as the day of time, the month of time, the year of time, the week, the quarter, etc. So I'll give you one sample of timetable that you can reuse in any of your future assignments as well. In this case, it just asks for month and week, but let's say we had other questions that you would want to add on to it. So I'm going to make one timetable which has multiple units of time in it. So I just made this table. It's called dim time or dim dimension table time. I have a time ID, which is the primary key. Then I have the date, year, quarter, month, week number, day of the week, and day of the year. That way, we have different units of time. So you can reuse this table anytime you need the time dimension table again. I know for this question, it only asks for week and quarter, but let's have it all. Now we have all the dimension tables. We need to make the fact table. I'll start with another table, call it fact underscore service underscore visit. This is just to indicate that the grain of this table or this fact table is each service visit. Now, what should be the primary key of this table? Can just mechanic ID be sufficient? No, because one mechanic may be looking at multiple services. Is just time enough? No, maybe at one time there are multiple vehicles there for repair. Is just the service code enough? No, one service code may be applied to, for example, if you have a service code for tire rotation, it may be applied to multiple vehicles. If you have a vehicle ID, well, again, that's not sufficient because one vehicle hopefully will come to your repair shop multiple times during its lifetime. And then again, for diagnosis, same thing. We cannot have just one diagnosis ID sufficient to have all the different service. So it looks like we need a combination of all of these 5 IDs as a primary key for the fact service visit table. So the primary key of the fact table is going to be 5 fields combined together. This is a 5 attribute primary key. So let's go ahead and write the primary key for these tables. So we have service code, and we'll indicate that this is a primary key. Then the next one we have is vehicle ID. Again, this is also a primary key. Then we have diagnosis ID, also used as a primary key. And I will highlight this and hit this blue arrow to get a few more fields. Okay. Then we need a mechanic ID. This is also a primary key, or rather part of the primary key. Then we have time ID, which is also part of the primary key. So all of these are part of the primary key. And we had 2 measures in our problem description, one of which we identified as average cost of service. So we said cost of service is going to be one of the measures. And then another one we identified in a previous video as time in service. So those 2 need to be included in our fact table as measures. So let's go ahead and include them. First one is going to be cost. And another field is going to be time in service. Now, so we have all our fields here. One thing I want to show you is that fact table is going to be connected to dim service table through service code. So service code, which was a primary key in the service table, is being reused as a foreign key in the fact table. So we need to also indicate that service code here in the fact table is part of the primary key, but it is also a foreign key. I'm going to copy this. Same thing. Vehicle ID in the vehicle table is the primary key, which is being reused in our fact table as a foreign key. So next to the vehicle ID, I need to indicate this is also a foreign key. Same goes for diagnosis ID in the diagnosis table, also for the mechanic ID in the mechanic table. All of these, which were primary key in their previous table, are part of the primary key in the fact table and the foreign key in the fact table as well. So that's what the complete picture is. So far we have shown all the tables or entities. We haven't shown the relationships of how these are related to each other. In these diagrams, not every table needs to be connected with everything. Based on the relationship, only some of the tables are going to be connected with each other. In a star schema, all the dimensions table are connected to the fact table such that the relationship towards dimension table is 1, 1, and towards the fact table it is 1, many. So to draw those relationships, we have these relationship lines. So let's look at some of them and find which one is correct for us. So we are looking for one which says 1, 1, 1 on one side and 1, many on the other one. So it's this one. We can drag this here, and the one side of it should be connected to one of the dimension tables, and the many side should be connected towards the fact table. If you want, we can copy and paste this multiple times so we can reuse them. So one side goes to the dimension table, many side goes to the fact table. Do this for all of the tables. One side to the mechanic table, many side to the fact table. Again, one side to the dimension table, many side to the fact table. One more. Lastly, I'm connecting the vehicle table and make sure they connect fully. So here. Now, if you see that some of them are not connected properly, you can move it around so that they look connected. If some of them are weird like this, you can select those. Go to the options on the right hand side. I'll show you a few options here. One of them under line, so you will have the style tab, then you will have line, and this icon, this wiggly kind of icon here says what kind of line do we want. So you will select the one that says straight. Then it is always going to have a straight connector without having these bends in the line. Then you can reorganize your diagram using the lines as you see fit. Another tool I wanted to show you is if you select the line, let's say you didn't select the 1, many or 1, 1 properly, then you also have the option to go to the style tab, look at the line, and there are two options here, one for the start and the finish. So what is the shape going to be on the start of the line? Line start, and then it says 1, 1. What is going to be the shape at line end is 1, many. So you can use those to actually change the cardinality of the line as well if you wish. Finally, you can go open a snipping tool, take a snip of it, and paste it in your solution.